Tonight, you are going to die a little. Not metaphorically, not poetically, biologically. When you fall asleep tonight, the version of you that exists right now, the one reading these words, with this exact configuration of thoughts, memories, and active neural connections, will begin to come apart. And the person who wakes up tomorrow morning will not be exactly you. They will have your memories, your face, your habits, your name. But at the cellular level, at the level of synaptic connections and protein structures, and the precise chemical balances that define your moment-to-moment consciousness, they will be a reconstruction. A very good reconstruction, but a reconstruction nonetheless. And here's what's strange. You already know this happens. You just don't think about what it actually means. Let's start with what sleep actually is. Because most people think of sleep as the absence of something. The absence of wakefulness. The absence of thought. A pause button. A blank space between days. That's almost exactly backwards. Sleep is not a pause. Sleep is the most metabolically expensive, neurologically complex, and structurally critical process your brain runs. It requires more coordination between different brain regions than almost any waking activity. It is, in a very real sense, the most important thing your brain does. And it has to happen while you're unconscious. Because if you were awake for it, it would be unbearable. Here's why. Every moment you are awake, your neurons are firing. Every thought, every sensation, every decision, every memory being formed. All of it happens through synapses. Tiny electrochemical gaps between neurons where signals jump from one cell to another. Every time a synapse fires, it changes. The connection gets slightly stronger. The gap narrows fractionally. The signal becomes a little easier to transmit next time. This is called synaptic potentiation, and it's the physical mechanism of learning. Every experience you have today literally reshapes the microscopic architecture of your brain. The conversation you had this morning, the route you drove, the face you recognized, the problem you solved, all of it left a physical mark. By the time you're ready for sleep tonight, your brain has been accumulating these changes for 16 hours. And here's the problem. If synaptic strengthening just kept happening indefinitely, if every connection just kept getting stronger and stronger, your brain would eventually become saturated. The signal-to-noise ratio would collapse. Everything would feel equally important. Nothing would stand out. Memory would become impossible. New learning would become impossible. The brain would overheat. Literally. Neurons firing at maximum strength consume enormous amounts of energy. A brain running at full synaptic potentiation would burn through its glucose reserves in hours. So every night, your brain does something extraordinary. It resets. In 2003, two neuroscientists, Giulio Tononi at the University of Wisconsin and Chiara Sorelli, proposed what they called the synaptic homeostasis hypothesis. The idea was elegant and, at the time, controversial. They argued that the core function of sleep, the actual reason it exists, is to downscale synaptic connections across the brain, to systematically weaken the connections that accumulated during the day, to turn the volume down, not eliminate them, downscale them, proportionally reduce their strength so that the relative differences between connections, the signal, is preserved, but the overall energy cost drops. The important memories stay more important than the unimportant ones. But the whole system gets quieter. It is, in the most literal sense, a nightly factory reset. For years, this was theoretical. Then in 2017, Tononi's team published evidence that provided direct physical confirmation. Using electron microscopy, they examined the actual synapses in mouse brains, measuring their physical size before and after sleep. Synapses were measurably larger after waking. After sleep, they were measurably smaller. On average, synaptic connections shrank by about 18% during sleep. 18%. Every night. Across most of your brain. The brain you wake up with every morning is physically smaller at the synaptic level than the brain you went to sleep with. It has been pruned, compressed, optimized. And here's what makes this stranger. This pruning is not random. Your brain doesn't shrink everything equally. The connections that fired most recently, most repeatedly, most strongly, the important ones, the emotional ones, the ones tied to survival, those are protected. The synaptic homeostasis process appears to selectively preserve the connections that matter most while cutting back the ones that don't. Your brain is editing you while you sleep, deciding what stays, what fades, what tomorrow's version of you will remember and what they won't. But synaptic rescaling is only part of what happens. Because while your brain is doing this, something else is running simultaneously. Something that was only discovered in 2013 and that neuroscientists still can't fully stop talking about. Your brain has a cleaning system. In the rest of your body, the lymphatic system clears waste. Cellular debris, metabolic byproducts, misfolded proteins. The lymphatic system carries all of it away. But the brain is sealed behind the blood-brain barrier. The lymphatic system can't reach it directly. For a long time, neuroscientists assumed the brain simply had a different, slower method of clearing waste. They were wrong. In 2013, Maiken Nedergaard at the University of Rochester discovered something entirely new. The brain has its own dedicated waste clearance system. She called it the glymphatic system. Here's how it works. Cerebrospinal fluid, the clear liquid that surrounds and cushions your brain, is pumped through channels that run alongside blood vessels deep inside brain tissue. This fluid flows through the brain, collecting waste products along the way, and then drains out carrying the debris with it. But here's the critical detail. During waking hours, this system runs at low capacity. The channels it uses are narrow. During sleep, the brain cells shrink by up to 60%. The channels open up. Cerebrospinal fluid floods through at a rate 10 times higher than during waking. Your sleeping brain is being power washed. And what exactly is being washed away? Among other things, amyloid beta and tau proteins. The same proteins that, when they accumulate and aren't cleared, form the plaques and tangles associated with Alzheimer's disease. The glymphatic system runs primarily during sleep, specifically during deep, slow-wave sleep. If you cut that sleep short, if you sleep 6 hours instead of 8, the system doesn't fully complete its cycle. The trash doesn't get taken out. Night after night, week after week, the proteins accumulate slightly faster than they're cleared. And over a lifetime, that difference compounds. Chronic sleep deprivation is not just tiredness. It is a failure to maintain the brain. It is, in slow motion, allowing the accumulation of the physical substrates of neurodegeneration. This is not a hypothesis. This is what the research shows. But let's go further, because we haven't even gotten to the strangest part yet. While your brain is being pruned and washed, while synapses are shrinking and proteins are being cleared, your memory is being reorganized. Not just consolidated, reorganized. During waking hours, memories are initially stored in the hippocampus. Think of the hippocampus as a temporary holding area, a RAM buffer. It can hold information, but it's not designed for long-term storage. It's too small, too volatile, too easily disrupted. The long-term storage system lives in the cortex. Vast networks of neurons distributed across different regions, holding different types of information, connected in ways that allow them to be retrieved by context, by emotion, by sensory cues. The transfer from hippocampus to cortex, the process of turning a day's experience into a lasting memory, happens during sleep. Specifically, it happens during a remarkable cellular conversation that occurs while you dream. During slow-wave sleep, the hippocampus replays the day's experiences in compressed, fast-forward form. It broadcasts these replays to the cortex in sharp waves called sharp wave ripples. The cortex, which is oscillating in its own slow rhythm, receives these broadcasts. Where the hippocampal ripples arrive during a cortical up state, a moment when cortical neurons are already active and receptive, a connection forms. The memory begins to be written into long-term storage. This isn't a metaphor. Researchers have literally recorded this process happening. They've watched the hippocampus replay spatial memories in sleeping rats, identified the same sequence of neural firing that occurred during learning, and confirmed that disrupting these replays impairs memory consolidation. Your brain is rehearsing your life while you sleep, running through what happened, deciding what's worth keeping, and writing the important parts into permanent storage. The you who wakes up tomorrow has literally rewritten the day's events overnight. Not changed the facts, but changed the connections, strengthened some associations, weakened others, integrated new information with old frameworks, updated the model. And this rewriting is not neutral. Emotion plays a significant role in what gets consolidated. The amygdala, the brain's emotional processing center, is particularly active during REM sleep, the phase when most dreaming occurs. Memories with strong emotional content receive preferential consolidation. They are flagged, replayed more frequently, and woven more deeply into the cortical network. This is why traumatic memories are so persistent, and why a piece of information you learned while emotionally engaged is easier to recall than something you studied while bored and distracted. Sleep doesn't just preserve your memories. It curates them. It prioritizes them according to emotional weight. The brain that wakes up tomorrow has, overnight, decided which parts of today mattered most. But here's the question that all of this raises. If your synapses have been rescaled, if your waste products have been cleared, if your memories have been reorganized, reweighted, and partially rewritten, if the physical structure of your brain is measurably different than it was 8 hours ago, then who exactly wakes up? Philosophers have a version of this question: the ship of Theseus. If you replace every plank in a ship one by one until none of the original material remains, is it still the same ship? Your brain doesn't wait years to replace itself. It does a significant version of this every single night. The continuity you feel, the sense that you are the same person who went to sleep, is constructed. It's a narrative your brain assembles each morning using the memories it kept, the identity it maintained, and the body it woke up in. But the neural substrate that generates that narrative has changed. The hardware running the software of you is different. The weights have been adjusted. The cache has been cleared. The architecture has been slightly but measurably modified. Neuroscientist David Eagleman has written about this. He points out that the brain you're using right now to read these words is not the brain you were born with. It is not the brain you had 10 years ago, 5 years ago, or even yesterday. The self is not a fixed thing. It's a process, a continuous reconstruction that your brain performs so smoothly and so consistently that you never notice the seams. Sleep is where the most dramatic version of that reconstruction happens. Every night, you close your eyes and your brain takes itself apart and puts itself back together. Quieter, cleaner, reorganized, with the day's experiences integrated and the unnecessary connections pruned back. And every morning, something opens its eyes and believes without question that it is you. And it's right, mostly. But also, it is the version of you that your sleeping brain decided to build. It kept what it thought was important. It cleared what it thought was waste. It strengthened the connections it thought you'd need. It filed away the emotional experiences it thought would shape you. You didn't get a vote. You were unconscious. The most important decisions about who you are tomorrow, which memories survive in full fidelity, which fade slightly, which connections carry more weight, which less, are made while you have no awareness whatsoever. Every morning, you wake up as someone who was built for you overnight. And then you spend the whole day being that person, convinced, completely and without doubt, that you have been you all along.